Hello everyone, I am Dr. Venkateswararao. In the last video, that is buffer solutions, concept of buffer solutions, we had gone through the significance of buffer solutions and what is meant by buffer solution and types of buffer solutions. Okay, so in this video we shall see the action of buffer solutions, that is buffer action of acidic buffer, buffer action of basic buffer. Okay, now let us see buffer action of acidic buffer and buffer action of basic buffer one by one. Okay, let us see, we shall see the buffer action of acidic buffer. Acidic buffer. I already told you that acidic buffer is example for buffer solutions of mixtures, buffer solutions of mixtures, and the acidic buffer is mixture of solution of weak acid and a salt of weak acid with a strong base. Okay, so let us consider the acidic buffer of acidic buffer, acetic acid and sodium acetate buffer. So with that with that example we shall understand the action of buffer, action of acidic buffer. Okay, so example for acidic buffer is acetic acid. Actually acidic buffer is a mixture of solution of weak acid and a salt of weak acid with a strong base. Okay, this is the example for acidic buffer. Okay, so here the acetic acid is weak acid and sodium acetate is a salt formed from the weak acid with a strong base. So weak acid is a acetic acid is a weak acid, that means it is weakly ionized, that is that can be represented as acetic acid. So it is weakly ionized. So weak ionization can be represented as I already told you, weak ionization of an acid is represented with a double headed arrow. Okay, so CH3 COO minus plus H plus and sodium acetate CH3, let us see the ionization of sodium acetate. So sodium acetate is a strong base, sodium acetate is a strong electrolyte. Okay, so its dissociation upon its ionization it forms CH3COO minus and Na plus. Na plus. So already I told you acidic buffer is a solution of mixture, solution of, I repeat, you please keep this point in your mind, it is a solution of mixture of weak acid and a salt of weak acid with a strong base. So in acidic buffer these two are combined together, these two are in the same solution, these two are in the same solution. You should keep that point in your mind, these acetic acid and sodium acetate are present in the same solution. Okay, you should keep that point in your mind. Okay, so acetic acid is a weak acid, but it is weakly ionized. So weak ionization of acetic acid forms a very less number of acetate ions and H plus ions. But is a sodium acetate is a strong electrolyte, it undergoes complete ionization to form acetate ions and Na plus ions. But these two are present in the same solution. Sodium acetate, on ionization of sodium acetate gives acetate ions and acetic acid on ionization of acetic acid, that forms also acetate ions. Due to common ion effect, actually the ionization of acetic acid is very weak, but ionization of sodium acetate is very high, that is it undergoes complete ionization and it forms acetate ion. This also forms a acetate ion due to common ion effect, because sodium acetate liberate acetate ions and acetic acid liberates acetate ion. Due to common ion effect, because owing to the complete ionization, high ionization of sodium acetate forms more number of acetate ions. Due to common ion effect, the ionization of acetic acid is further suppressed, that is ionization of acetic acid is decreases due to the complete ionization or high ionization constant of sodium acetate. Okay. So, due to common ion effect, the ionization of acetic acid is further suppressed. Okay, further suppressed, that is ionization of acetic acid decreases. Okay, ionization of acetic acid is decreases. Okay. So, due to the common ion effect, more number of acetate ions are formed and less number of H plus ions are formed. Less number of H plus ions are formed. So, due to common ion effect, acetate ion CH3COO minus ions increases and H plus ions decreases. The concentration of H plus ions are decreases. Now, we shall see what happens if we add strong acid to this acidic buffer. Now, we shall see if we add strong acid, to this acidic buffer. Okay, addition of strong acid to acidic buffer, what happens? So, strong acid, so we are adding strong acid. Strong acid means it is a source of H plus ions. So, we are adding strong acid means, okay, that means we are adding H plus ions to this buffer. We are adding H plus ions to this buffer. So, H plus ions from strong acid combines with H plus ions from strong acid combines with acetate ions, that is CH3COO minus plus H plus ions that forms acetic acid, Again, this acetic acid is a weak acid. Okay, I repeat, addition of strong acid to acidic buffer. Okay, so what is buffer? Buffer, it optimizes, it resists the pH change upon addition of strong acid or upon addition of strong base or upon dilution. That should resist the pH change. Okay, so what we are doing? We are adding strong acid to acidic buffer. So, we are adding strong acid. Strong acid means it is a source of H plus ions. Okay, when we are adding H plus ions, these H plus ions from strong acid combines with acetate ion. More number of acetate ions present in the buffer. So, that acetate ions combines with H plus ions to form acetic acid. So, acetic is formation of acetic acid, that is the formation of weakly ionized acetic acid does not alter the pH change effectively. So, pH change is we could not observe the drastic pH change. Okay. So, in that way pH is optimized. So, even if we add strong acid to the acidic buffer, that forms the H plus ions from strong acid combines with the acetate ions to form acetic acid, weakly ionized acetic acid. Formation of weakly ionized acetic acid does not alter the pH of a buffer solution effectively. Okay, in that way, okay, in that way the pH is optimized, and we could not observe the drastic pH change upon addition of strong acid. So, buffer is, what is buffer? Buffer is a person or a thing which reduces the shock. Okay, here the shock in the sense in the form of strong acid, we are adding strong acid. Okay, we are adding strong acid to the acidic buffer. This is a shock, but the shock is optimized by the formation of weakly ionized acetic acid. So, formation of weakly ionized acetic acid does not alter the pH effectively. So, owing to the formation of acetic acid in the solution, and this is the mixture of a solution. So, in the solution concentration of acid increases, concentration of acid increases. Okay. So, from this it is evident by the addition of, it is evident from the above reactions is that when we are adding strong acid to acidic buffer, that leads to the formation of weakly ionized acetic acid, okay na? And that leads to the increase in the concentration of acid and decrease in the concentration of salt, because the H plus ions we are adding, the H plus ions are we are adding to the acidic buffer that reacts with the acetate ions which are formed from the salt. So, salt concentration decreases and the acid concentration increases. Okay. So, addition of strong acid to acidic buffer increases the acid concentration, and decreases the salt concentration, We can memorize the whole statement with a short mnemonic that A. Short mnemonic, that is A. Addition of acid to acidic buffer. For acidic buffer, addition of strong acid increases the acid concentration. So, we can memorize the whole statement with this short mnemonic. Okay. So, this with the help of this mnemonic we can recollect the entire concept or we can recollect the entire reactions that are that happens when we are adding strong acid to acidic buffer. Okay. You please keep this mind in your you please keep this mnemonic in your mind. So, for acidic buffer, strong acid is added, that leads to the increase in the concentration of acid. Acid concentration increases. So, with this help of mnemonic we can memorize the whole statement. Okay, what is that statement? Addition of strong acid to acidic buffer leads to the formation of weakly ionized acid. Okay, that formation of weakly ionized acid does not alter the pH effectively. Therefore, pH is optimized. So, we could not observe the drastic pH change upon addition of strong acid. Okay, so we can memorize that whole concept with a mnemonic, that is A. So, for acidic buffer, addition of strong acid leads to the increasing the concentration of acid. Acid concentration increases. Now we shall see. What happens if we add strong base to the acidic buffer. Okay. Again, acidic buffer is a weak acid and it is a salt of weak acid with strong base. Ionization of acetic acid is weak ionization of acetic acid is represented like this, and ionization of sodium acetate is CH3COO minus plus Na plus. Now, what happens when we add small amounts of strong base? Addition of strong base to acidic buffer. Let us see what happens when we add strong base to acidic buffer. Okay, what we are doing here, we are adding strong base to acidic buffer. Strong base means it is a source of OH minus ions. It is a source of OH minus ions. So, that OH minus ions reacts with acetic acid. Okay. So, here that OH minus ions from strong base combines with acetic acid and it forms acetate ion CH3COO minus plus Na plus H2O. Okay, so addition of strong base. Strong base, what is strong base? It is a source of OH minus ions. So when we are adding strong base, the OH minus ions from strong base combines with acetic acid and forms acetate ions. So due to this, owing to the formation of acetate ions, the concentration of acid in the mixture decreases. The concentration of acid in the mixture decreases and the concentration of salt increases. Okay, what happens? Addition of strong base to acidic buffer. We are dealing with addition of strong base to acidic buffer. What happens? Strong base is a source of OH minus ions. That OH minus ions combines with acetic acid. So acetic acid OH minus ions combines with acetic acid to form acetate ions. So due to the formation of acetate ions, the concentration of acetic acid in the mixture decreases and the concentration of salt increases, because acidic buffer is a mixture of weak acid and its salt with a strong base. So that is a mixture. So in that mixture, acid concentration decreases and salt concentration increases. So addition of strong base to acidic buffer, that leads to the salt concentration increases and acid concentration decreases. So addition of strong base to acidic buffer increases the salt concentration and decreases the acid concentration. So from these reactions, it is evident from the above these reactions, okay, addition of strong base to acidic buffer increases the salt concentration and decreases the acid concentration. We can memorize the whole statement with a short mnemonic that ABS, ABS. Okay, what is that? What is that mnemonic? ABS. Okay, for acidic buffer, strong base is added, salt concentration increases. Salt concentration increases. Okay, so for acidic buffer, when we add strong base, that leads to the formation of a strong that leads to the increase in the salt concentration. Okay, so with this mnemonic we can memorize the whole statement, or what happens when we add strong base to the acidic buffer. Okay, now we shall see the buffer action of basic buffer, buffer action of basic buffer, action of basic buffer. I already told you that basic buffer is example for buffer solutions of mixtures, and example for basic buffer is a weak base. Basic buffer is a mixed solution of mixture of weak base, and it's a salt with a strong acid, that is NH4Cl, ammonium chloride. So that is the example for basic buffer. Okay, so that is the buffer solution. So that is a mixture of a weak acid and a salt of weak acid with a strong and it is a mixture of a weak base and it's a salt with a strong acid, and salt of a salt with a strong acid. Okay, let us see the ionization of weak acid, weak base, sorry. Let us see the ionization of weak base. NH4OH is a weak base. It undergoes weak ionization. So weak ionization of base can be represented with a double headed arrow. So NH4 plus OH minus ions. Okay, in this mixture there is a salt, that is NH4Cl, ammonium chloride, that is a salt of weak base with strong acid. So that also undergoes ionization, but that undergoes complete ionization. It undergoes complete ionization, that is NH4 plus Cl minus ions. Okay, you should keep this point in your mind. This is a mixture. So in this mixture, ammonium hydroxide is there and ammonium chloride is there. So due to weak ionization of NH4 plus ions are formed and complete ionization of NH4 plus ions also formed. But overall NH4 plus ions are more in number, because due to common ion effect, because ammonium chloride also liberates NH4 plus ions, and ionization of weak ionization of ammonium hydroxide also liberates NH4 plus ions. But due to the common ion effect, NH4 plus the ionization of ammonium hydroxide is further suppressed. That is ionization of sodium hydroxide, ionization of ammonium hydroxide is further decreased because due to the common ion effect, because already this chloride forms ammonium NH4 plus ions. Because it undergoes complete ionization, it forms eventually it forms more number of NH4 plus ions. So there is no that is a scope for not to undergo the ionization of ammonium hydroxide. Okay, so due to common ion effect, NH4 plus ions, number of NH4 plus ions are increases and number of OH minus ions decreases. Number of OH minus ions decreases. So this number increases and this number decreases. Okay, now let us see what is buffer. Buffer that should reduces the shock, even by the addition of a strong acid or addition of strong base. Let us see what happens if we add strong base to the basic buffer. First we shall see addition of what happens when we add strong base to the basic buffer. Okay, so addition of strong base to basic buffer. Okay, addition of strong base to basic buffer. Okay, what we are doing, we are adding strong base to basic buffer. So what happens? Strong base is a source of OH minus ions. Okay, that OH minus ions combines with NH4 plus ions which are in great number. Okay, so NH4 plus ions. Okay, that OH minus ions from strong base, combines with NH4 plus ions. These NH4 plus ions are formed from the complete ionization of ammonium chloride. So this forms ammonium hydroxide. Again ammonium hydroxide. Formation of weakly ionized ammonium hydroxide does not alter the pH effectively, because it is weakly ionized. Okay, it does not undergo complete ionization, it is feebly ionized. So formation of weakly ionized ammonium hydroxide does not alter the pH effectively. That means pH, we could not observe the pH change, drastic pH change, because there is a formation of weakly ionized ammonium hydroxide that does not undergo complete ionization. So pH levels are not increases. Okay, so ammonium hydroxide. So addition of a strong base to basic buffer forms weakly ionized ammonium hydroxide. So these NH4 plus ions are from salt, ammonium chloride, this is a salt. These NH4 plus ions, so OH minus ions are combines with NH4 plus ions that are being provided from the complete ionization of ammonium chloride. So this leads to the decrease in the salt concentration. It leads to the decreasing in the salt concentration and increases the base concentration. Okay, so addition of strong base to basic buffer leads to increase in base concentration and decrease in salt concentration. Decreases the salt concentration. Okay, so addition of strong base to basic buffer leads to increase the base concentration, increases base concentration and decreases salt concentration. Therefore from these reactions it is evident that addition of strong base to basic buffer leads to the formation of weakly ionized ammonium hydroxide. The formation of weakly ionized ammonium hydroxide does not alter the pH effectively. That means we could not observe the drastic pH changes in the buffer solution, in the solution. Okay, and it leads to the increase, leads to the increase in base concentration, it leads to increase in base concentration and decrease in salt concentration. So we can memorize the whole statement with a small mnemonic, that is, what is that mnemonic? BBB. Okay, for basic buffer, addition of strong base leads to the increase in base concentration. Okay, so for basic buffer, addition of strong base leads to the increase in base concentration. So with this mnemonic we can memorize the whole concept and we can memorize what is happening there. Okay, now let us see what happens when we add a strong acid to basic buffer. Okay, now we shall see what happens when we add addition of strong acid to basic buffer. Okay, addition of strong acid to basic buffer. Okay, addition of strong acid to basic buffer. Okay, so you please keep this point in your mind. Basic buffer, what is basic buffer? It is example for buffer solutions of mixture, and it is a mixture of solution of weak base and it's a salt with strong acid. Okay, and this undergoes ionization like this. Ammonium hydroxide is weakly ionized and it is represented as represented with double headed arrow, and ammonium chloride undergoes complete ionization. So what happens? Let us see what happens when we add strong acid to basic buffer. Strong acid. So what we are doing here? We are adding strong acid. Strong acid is a source of H plus ions. Strong acid is a source of H plus ions. So that H plus ions combines with ammonium hydroxide. That H plus ions are combines with ammonium hydroxide. Okay, that H plus ions combines with ammonium hydroxide and that forms NH4 plus H2O. NH4 plus H2O. So what we are doing here? Strong acid. Strong acid is a source of H plus ions. Those H plus ions from strong acid combines with ammonium hydroxide forms the NH4 plus ions plus water. So here NH4 plus ions are formed. So what happens? These H plus ions reacts with ammonium hydroxide base. H plus ions reacts with base. So base concentration decreases. Base concentration decreases. The amount of base is reducing when we are adding strong acid. So when we are adding strong acid, that strong H plus ions from strong acid reacts with the base. Owing to that base concentration decreases and salt concentration increases. Okay, so H plus ions from strong acid reacts with the weak base and it forms NH4 plus ions. Due to this reaction, the concentration of base decreases and the concentration of salt increases. So addition of strong acid to basic buffer leads to increase in salt concentration and decrease in base concentration. base concentration. So from this reactions it is evident that addition of strong acid to basic buffer leads to the formation of ammonium ions, NH4 plus ions. Okay, here the H plus ions from strong acid reacts with ammonium hydroxide, which is a weak base. Due to this reaction in the mixer, the concentration of base decreases and the concentration of salt increases. Okay, we can memorize this statement with a short mnemonic that is BAS. With this mnemonic we can memorize the whole statement. So for basic buffer when we add strong acid, that leads to the increase in the salt concentration and decrease in the base concentration. So with this mnemonic we can understand the whole concept and what is happening there. Okay, let me sum up this lecture. Let me sum up this lecture. Okay, I want to sum up this lecture with mnemonics. Okay, so what happens in the first at first we saw that buffer action of acidic buffer. Okay, there are two mnemonic. What is AAS? AAA. Okay, AAA. Addition of acid, addition of for acidic buffer, addition of acid, acid concentration increases. Okay, next addition of base to acidic buffer increases the salt concentration. Okay, and when we go with the basic buffer BBB, for basic buffer addition of strong base increases the base concentration. Okay, and finally addition of strong acid to basic buffer. So basic buffer, for a basic buffer addition of strong acid leads to the increasing the salt concentration. So with this mnemonics we can memorize what is happening when we add strong acid to acidic buffer or strong base to acidic buffer or strong acid to basic buffer or strong base to basic buffer. So we can memorize the whole concept with this mnemonics. I hope you all understand this concept. Thank you.